We're going to go ahead and take a look at roots of numbers and roots of expressions with variables. Now, if you're looking at the nth root of x, it really means what number multiplied by itself n times gives you x. This little n here is called your index. It's the root that you're taking. So the fifth root of the fifth root of 0 means what number multiplied by itself 5 times gives me 0. And well, that's 0. So this down here means what number multiplied by itself 4 times is 16. Well, what number multiplied by itself 4 times is 16 is 2. Because 2 times 2 is 4, times your third 2 is 8, times your fourth 2 is 16. So this one means what number multiplied by itself 3 times, because that's our index, gives you 27. That is a positive 3. This one would mean what number times itself 3 times gives you a negative 8, and that is a negative 2. The bottom one here, what number multiplied by itself 4 times is negative 16? Some of you might think it's negative 2, but let's check. A negative 2 times a negative 2 is 4. Times your third negative 2 is negative 8. Times your fourth negative 2 would be positive 16. So negative 2 doesn't work. Well, positive 2 won't work either because 2 times itself 4 times would still be positive. So this one has no real solution. It does have a solution, and we'll get to what that is later in this chapter, but it does not have a real solution, as in a real number. So let's take a look at this one here. There's a couple ways we can go about doing this. The first way is we're going to go ahead and try to rewrite the inside as perfect squares. We want to write them as perfect squares because we have a square root. Well, we have 16, which is a 4 squared. X to the 6 is an x squared, an x squared, and an x squared. Now, your square root's going to cancel out each one of these squared. So it's going to leave you with a 4, an x, and an x. So that leaves you with a 4x cubed. So we said it is a 4 and it leaves you with an x. Well, I don't know if you want to be left with your x. Normally you want to be hanging out with your current significant other. So you might want to be paying attention to that. This one here, we also have a square root, so we're going to still leave that negative in front. Oh, I'll show you a second way this one could be done. Sorry about that. Now, a square root is a 1/2 exponent. So you could write it with a fractional exponent. Now you have your 4 squared, you have your x to the 6, and you have exponents raised to an exponent. So you could just go ahead and multiply your exponents. Apply that exponent to each one, multiply your exponents, and you still get the same answer as you did before. It can be done both ways. Doesn't make a difference. This one here, you could use the fractional exponent thing again. So you'd have your 1/2 applying to your 4th power, which gives you it to the 2nd power. Looking at this one here, we're dealing with the 5th root, so we're going to want to try to write the inside as perfect 5th powers. Well, 243 is just 3 to the 5th. This is an a to the 5th, and another a to the 5th. And that's a b to the 5th, a b to the 5th, and a b to the 5th. Well, your 5th root then will cancel out all your 5th powers. And so you get a 3, an a, a b, and a b. Well, you could write that as a 3a squared and a b cubed. Looking at this one here, we have a square root of a negative. And just like what we had back here, we said we can't take an even root of a negative. An odd root of a negative works out nicely. But if it's an even root with a negative on the inside, it can't be done. Some of you might think, well, it's -2, but really means what number times itself 2 times is -4, and -2 times a -2 doesn't work. So we're going to write no real solution. So go ahead and try to do these two quickly, and then watch the video. You can write the inside on this one here as perfect squares. Your square root then cancels out each one of those squares, and it leaves you with a 3x to the 4th with your plus or minus. This one here, it could be done a couple ways. This one here could also be done with a 1/2 exponent, but I did not choose to do it that way. We could write it as perfect squares on the inside, and then your square root will cancel each one of these squareds out, leaving you with that negative in front and just your parentheses. Each one of the parentheses is the same, so you could write it as that all cubed. If you did the fractional exponent thing, you would then take a square root, which is a 1/2 power, exponent raised to an exponent. 6 times 1/2 is 3, and you would still get the same answer, except you got to make sure you have that negative hanging out in front. There we go. Okay, pause the video, do these two quickly, and then watch it. Once again, we'll start off writing everything as 5th powers, and then your 5th root cancels each of those 5th powers out, leaving us with a 2, an x, and a y squared. Here we have a square root of a negative, and that doesn't work out to be a real number. So we write no real solution. Here we have the 6th root of a t to the 6th. Well, the 6th root and your exponent of 6 cancel each other out, and we get t. But technically, it's absolute value of t. Take a look at the side note down here. The 6th root of 2 to the 6th would be the 6th root of positive 64, which would be positive 2. Same idea down here. The 6th root of negative 2 to the 6th. Well, when you work out the inside, that's also positive 64. And then you can take the 6th root of that positive 64. Because we had said before, we can only take an even root when the inside's positive. And well, the inside ends up being positive on these. Same idea over here. So no matter what's on the inside being raised to a power, if it's an even root, we're going to get out positive answers. So we need to make sure that t is positive. To ensure that t is positive, we have to put the absolute value there. So write this one as 5th powers and work that out. So we write it as 5th powers, we get this. Our 5th root cancels out each one of those 5th powers, and then we can simplify a little bit. Try these two quickly. Here we get absolute value of x because it's an even root, and what we get out has to be positive. Write this as perfect cubes, and then your cube root cancels out all the cubes, and then we simplify. And here we have a snowman fighting with a polar bear.